For page 9 of your interactive notebook, you're going to get the half sheet that looks like this. We folded it in half to make it look like a book. And so you already have this. And then when you open it up, it looks like this. And so we're going to use this for page 9 of our interactive notebook. So whenever we're writing the equations given the graph, we actually started number 3 already, so that's where I'm going to be in as well. We already had that this parent function was absolute value of x. We already had that it moved left 2 and up 1. And now I told you to ignore the vertical stretch in the past. And so now we're actually going to look at how we figure out what that vertical stretch or vertical compression is. So absolute value normally is going to be at the origin where the v starts. And then it's going to go right 1 over 1 as the pattern from the v part, left 1, up 1. This v part right here, it actually does not go right 1, down 1. So we know that as a result, there is going to be a vertical stretch or compression. And so had this been the parent function and there was no vertical stretch or compression, if it reflected over the x-axis, if it had gone left 2 and up 1 and that's all it did, then this is what the graph would look like. But because when you go right 1, it doesn't go down 1. It actually goes down, what is that, 2, 4, maybe 6-ish. We know there has to be a vertical stretch because the arms look like they've been pulled down. So there is a vertical stretch or compression. We're just not, or the vertical stretch in this case, we just don't know what that value of A is. And so that's our job right now, is to figure out what A is. So far, we already had this equation as negative absolute value of x plus 2, absolute value plus 1. That's what we had so far to make these 3 transformations happen. Now, A, that vertical stretch or compression, I'm actually going to sneak that little A right in there, and I'm going to figure out what that value of A is. So if it is not a nice number mathematically to figure out what A is, and I'll tell you what I mean by that in just a second, I can figure out the value by plugging in a point for x and y, and that'll help me solve for A. So for example, it looks like a point on this graph is -1, -5. So what I can do is I can plug that in for x, -1. I can plug that in for y, in this case g of x, -5. And then that will be give me a chance to be able to solve for -A. That's one way of doing it. If it is a nice number, that right 1, down 1 pattern that wasn't happening, in this case it's right 1, 1, 2, 3, 4, 5, 6. It's right 1, down 6, which means that y value of 1 turned into a y value of 6, or at least 6 down from the where it should be, or 6 down from right 1, down 6. So I'm thinking that value of A might be 6. And now I'm going to check to see if that's correct. So I'm going to plug in x equals -1 for that part, and then I'm going to plug in g of x equals -5 for that part. Now I'm going to follow PEMDAS. -1 plus 2 is 1. The absolute value of 1 is still 1. And then I'm going to multiply that by -A following PEMDAS. So far I have -A times 1, which is -A. And then that plus 1 over there on the side, I'm going to leave it. And then I'm going to have -A plus 1 equal to -5. Now I'm going to subtract 1 from both sides to get -A equals -6. And then I'm going to divide both sides by -1. And I know that A is going to be +6. So I now know that I have a vertical stretch by 6, which is what I thought it was at the beginning. And so if I put all this back together, I'm going to replace that A that I had here with the value that we just calculated. And so now this is the full equation that I would have for number 3. Okay, I'm going to go ahead and come over here to number 1, and I'm going to do the same type of thing. So what I'll do is I'll start with the parent function, which in this case is going to be x squared. I'm going to write down the transformations. So normally the parabola would be at 0, 0 for the vertex. It would go right 1, up 1, and left 1, up 1. So it should look like this. But the vertex instead went left 1 and down 8. So I'll write that for my transformations. There is no reflection. So all I have now, I'm thinking might be a vertical stretch, because from the vertex, if I go right one and I go up one, this is where the parabola would be if there was no vertical stretch or compression. But instead it went right one and up two. I'm thinking my value A is probably going to be 2. I'm going to check that now to see if that truly is correct, because sometimes you can't figure out what this actual value is. It's not a nice number. So I'm going to plug it in and solve for A. So I'll write g of x equals, in order to make it go left 1, I'm going to put x plus 1 and square it. In order to make it go down 8, I'll put minus 8, and then I'll put an A in front to indicate that there is a vertical stretch or compression, but I don't know what it is right now. So now what I'll do is I'll plug in a point. You don't want to use this point, -1, -8, because if you do, -1 plus 1 is 0, 0 squared is 0, and 0 times A becomes 0. It makes your A go away, so you can no longer solve for it. So pick any other point on here. I'm going to replace g of x with 0. I'm going to replace x with 1, and then I'm going to use PEMDAS to continue. PEMDAS says to do 1 plus 1 first, that's 2, squared is 4. So now I'm going to have 4 times A minus 8, and I'm going to set that equal to 0. You can't subtract 4 and 8. 4 minus 8, you're not allowed to make that -4A, because the PEMDAS says that you have to multiply by A first. So if I start solving this, I'll add 8 to both sides. I get 4A equals 8, and therefore now know that A must be equal to 2. So it's exactly what I thought it was going to be from the very beginning. So now if I just simply erase where I had up here where g of x was, and I replace that A with a 2, this now becomes my equation for this particular parabola. Okay, so now I'll do numbers 2 and 4. If you would like to pause and try this one on your own now to see if you understand yourself, you may do so. So for number 2, my parent function this time is the square root function. I see that there's a reflection over the y-axis, and there is no moving left or right. It still stays here. So normally it looks like this. It goes right 1, up 1. And so it stays in the same spot, 0, 0. So there is no movement left or right. But it looks like there might be a vertical compression this time, because if I go left 1 and up 1, the graph would go right there if this was just simply a reflection over the y-axis. But there is going to be more than just that. So I have to figure out what that value is for A for that vertical compression. So I'm going to write f of x equals, and then I'm going to write down A times the square root of negative x. This time my x is going to become negative. We're going to make that reflection over y happen. So it may be that when I go right 1 or left 1, it looks like I'm going up a half maybe. So it is possible that this value of A is 1/2, but it's also possible that it might be 1/3. It might be 2/5. You're just not sure. So what we're going to do is we're going to go ahead and solve it by plugging in a point. You may have gotten lucky if you said it was 1/2 or 1/3 and 2/5 and gotten the right answer, but we're not sure. So we're going to go ahead and plug in a value for a point. So looks like -1, -2, -3, 4. It looks like -4, 1 is going to be a point on that graph. So I'll plug that in. That negative on the outside of that -4 is going to turn that into a +4. I'll take the square root to make 2, and then I'll multiply it by A to make it 2A. Now the y value f of x was 1, so I'll replace that f of x with 1, and then I'll divide both sides by 2 to get A equals 1/2. So we were correct in thinking that A was equal to 1/2, so we'll replace that A there, and your function now becomes f of x equals 1/2 square root of negative x. And then finally for number 4, again, pause it if you think you can do this one on your own. For this one, we're going to use our cubic function for the parent function. We're going to move it. Okay, so let's do this real quick. Let's put this at the origin. So the cubic function has 0, 0 as one of its points. 1 cubed is 1. Negative 1 cubed is negative 1. 2 cubed is 8. And then negative 2 cubed is negative 8. So if you connect those dots, it looks something kind of like that. So what I'll do is I'll take this point right here, which is sitting at the origin, and I'll use that to figure out how much it moved left or right and up and down. So since that point 0, 0 matches this one, negative 1, 2, I know that this must go left 1 and up 2. You can either do a reflection over the x or you can do a reflection of the y. It actually doesn't matter. They both give you the same result. So I'm just going to go ahead and just do a reflection over the x. Now, this one also does not follow that 1, 1 pattern. It goes right 1, but it does not go down 1. And so it looks like there might be a vertical stretch. So my job is to figure out what that value of the vertical stretch is. So I'll write f of x equals a. In order to make it go left, I'm going to put x plus 1, but then I'm going to cube it. In order to make it go up 2, I'll put a plus 2 on the outside. And to reflect it over x, I'm going to make that a negative. Now I'm going to plug in a point. In this case, that point I can use is 1, negative 10. And so f of x is going to get replaced with negative 10. X will get replaced with 1. And then I'll use this to solve to figure out what the value of a is. Following PEMDAS, 1 plus 1 is 2, cubed is 8. Multiply that by a to get negative 8a. I cannot add that 2 because of PEMDAS having to multiply the negative 8 and a first, so I'm not allowed to add that 2. But I can start solving. I'll subtract 2 from both sides to get negative 12 equals negative 8a. I'll divide both sides by negative 8. And so now I know then that a has to be positive 12 over 8, which is the same thing as 4/3. So in this case, we were not able to tell from the graph that that vertical stretch would have been 4/3. So this is an example of a graph where you would have to plug in the value of x and y to figure out what a is. Okay, so now I'm going to replace that a with negative 4/3. No, positive 4/3. The negative was already there. So I'm going to replace that a with 4/3. And so now I have my function to be negative 4/3 parentheses x plus 1 cubed plus 2. And so here is the equation for this particular graph. Okay, and that's it for this page.